So up till now we have learned the various things in chapter 1 and we are finally going to solve exercise 1.1. Okay. Name the property under multiplication used in each of the following. So first is minus 4 by 5 into 1 is equal to 1 into minus 4 by 5. So any number, rational number multiplied with 1 is same as that number. Okay, same as that number. That is A. Okay, here A is minus 4 by 5. So which multiplication property we call 1 as we have just learned earlier. Anything we multiply by 1, we get 1. Okay, so the rule of 1 we have learned here. Multiplication of any number with 1 is 1. So we call 1 as multiplicative identity. A into 1 is 1 into A is equal to A, that rational number. Okay, so 1 is called multiplicative identity. Okay, and in case of multiplication, or we can also say that it is a case of commutativity of multiplication. That is, 1 is also a rational number. A rational number A into B is same as B into A, B into A. Okay, so this is also commutative. We have exchanged the position. Similarly, minus 13 by 17 into minus 2 by 7 is minus 2 by 7 into minus 13 by 17. So this is simply commutativity. 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 Minus 9 by 29 into 29 by minus 19 is 1. 1. Which property is this? This property is not discussed here. It is actually identity multiplicative inverse. Multiplicative inverse. That is any rational number when it is multiplied by reciprocal of that rational number we get 1. Okay. Suppose 2 into 1 by 2 is 1. 3 by 2 into 2 by 3 is 3 and 2 will cut out, we'll get 1. So this is called multiplicative inverse. It's not discussed in the chapter, but you should know. So we say what we say that a 1 by a is multiplicative inverse of a, or 1 by 2 is multiplicative inverse of 2. Suppose someone asks you what is multiplicative identity of multiplicative inverse of 2, then we will say 1 by 2. What is multiplicative inverse of 3 by 2? We will just inverse that number. You will say 2 by 3 is multiplicative inverse of 3 by 2. Okay. Tell what properties allows you to compute 1 by 3 into bracket 6 into 4 by 3 as 1 bracket 1 by 3 into 6 bracket close into 4 by 3. So you are saying that the position of numbers A, B, and C, it is not changing. Okay. If we designate 1 by 3 as A, 6 as B, and 4 by 3 as C, where position is not changing. Just that bracket is changing. Okay. Here the bracket is between B and C. Here the bracket has shifted to between A and B. So we are not changing the position. We are not using commutation. We are just changing their combination, their association. So it is associative property. Associative property. The product of two rational number is always a Raster number is closed for multiplication. We have studied closure property. So here's our exercise end. So what we have discussed so far, just summary. Raster numbers are closed under operation of addition, subtraction, and multiplication. Raster numbers we are talking about. But division, it is not closed. The problem arises for zero. Anything divided by zero is undefined. Okay, you take out your calculator, either in mobile or physical calculator, and you divide any number by zero. Then see what result is coming. Then second point, important point that we have learned so far, the operation addition and multiplication are commutative for rational numbers and associative for rational numbers. Addition and multiplication. Okay, we have seen that in the table. Addition and multiplication are commutative and associative. Commutative means A into B is equal to B into A. This is for multiplication. And for addition, A plus B is equal to B plus A. Similarly, association, for association, we need a third number also. A bracket, A into bracket B into C is equal to inside bracket A into B into C. Okay, we have associated. Similarly, for addition, associative property holds like A into bracket B plus C is inside bracket A plus B plus C. Okay. Rational number 0 is additive identity. Additive identity means if you add any rational number to 0, it will be same rational number. Additive identity. In addition, by adding 0, identity is not being changed. Similarly, 1 is multiplicative identity. If you multiply any number with 1, it is not going to change. A into 1 is 1 into A, that is A. Distributivity of rational number for all rational number A, B and C, A into bracket B plus C is equal to, so that is uh, rational number is distributive, following distributivity property of multiplication over addition and subtraction. Okay, this we have also seen. Between two given rational number, there are countless rational numbers. The idea of mean helps to find rational numbers between two rational numbers. Suppose rational number 2 by 3 and 5 by 3. So there is going to be countless, infinite numbers of rational numbers between these two rational numbers. Okay, you can find 1 is also a rational number, 2 is also a rational number, 3 is also a rational number. So you can find unlimited of rational numbers between these pairs. Okay, between 2 and 3. How? Write anything. 2 by 5, 2 by 7. Okay, so oh, sorry, 2 by 7, not simply you can find like this 2.3, 2.4, 2.5, and then you can, if you want to write it in the form of p by q, just remove the decimal. Right? So more better form 5 by 2, 12 by 5, 23 by 10. So all these are going to be between 2 and 3. So thank you very much.